Morning, guys. It is Wednesday, October the 24th, I think. I didn't get a chance to do a video yesterday afternoon. Just got busy with some things and just wasn't able to do that. But I did want to take a little bit of time today and go back over a little bit because we're starting to talk about the quadratic formula and how that can be used to find roots of a quadratic. So what I'm going to do first is I'm going to go through just a brief overview of what all we've discussed so far so that you can see why we're doing what we're doing and what's really going on rather than just a bunch of oblivious stuff that the teacher asked you to do, right? So I want you to understand conceptually what's going on. So I'm going to turn my screen around here. So let's go through the big overview here. So here's the quadratic formula. Here's the function that I'm going to be working with. Now, like I said, I want to take you back. I want to take you back through what all we've discussed. So far, I told y'all that when I'm working with quadratics, there's really 3 points that I'm interested in. 2 of them are the x-intercepts, if it has one, and the other one is the axis of symmetry. Okay, so if you also remember, sometimes the x-intercepts are called zeros, and axis of symmetry / vertex. You can tell I hadn't had my coffee yet this morning, so there it is right there. When it gets down to about right here, we know we're doing pretty good. All right, so I've showed y'all how to take one of these quadratic functions and find the axis of symmetry, which is that negative b over 2a. We took that and I'll just do a real quick run through for you. So that'd be a negative and -5 inside of there over 2 times 1. So that's going to give me 5/2. That would be my. Now I know this is not right. I just made up an example here. So I can take that and I can plug it back in. I can find the the y coordinate of the vertex. So I can say 5/2 squared minus 5 is 5/2. So that's going to be a 25/4 minus 25/2 minus 14. So say 25/4 minus 25/2. 14. And -20 1/4. Okay. So our vertex is 5/2 and a -20 1/4. Or you can say that's if you prefer, because I'm sure there's a math snob out there somewhere. Why didn't you make that one mixed too? If that'll make you happy, there you go. So then I talked about how we can take this and we can convert to vertex form. If we remember vertex form, look like that. The a value being the leading coefficient up here, and the h and k being your vertex coordinates. So it'd be y equals, in this case, it's 1 times x minus 2 1/2. Most people keep that improper. I'm not going to split hairs right now. Minus 20 1/4. Okay, so those are some of the things we've discussed so far. So that was always discussing with like the vertex. Also, the vertex right here is a minimum. You remember, it's the lowest point. It's also called the turnaround point or turning point. So a lot of different names that have been thrown around, right? Then we shifted over and we started talking about how can we find the roots of a quadratic. Now, graphically, we go, there they are. But that's not that's not going to cut it, right? We moved from that pretty quickly. So, we started out talking about, for one, why on earth am I setting this thing equal to 0? Used to they were like, set equal to y, And if you'll recall, we discussed how if the x-intercepts, the y coordinate is always 0. right? So when I want to find when y is 0, what I'm doing is I'm finding my x-intercepts. So we started out discussing, okay, we can factor. We can say, all right, negative 14, negative 5. Two numbers that multiply and give me negative 14, but add and give me negative 5, negative 7 and 2. So I have m minus 7, m plus 2 equal to 0. And I was able to say, all right, m minus 7 equals 0, m plus 2 equals 0. So we're going to solve. That's one root. That's another root. So in other words, this quadratic function looks something in the neighborhood of this. So negative 2, 4, 5, 6, 7. And its vertex was like 2.5 and down somewhere. It's somewhere way down here, right? So I can actually kind of sketch a little bit of a okay. So right here is going to be negative 14 because you remember that's the c value. So we got us a rough sketch of what this thing looks like. Now we're going to take this. I'm going to show you how this right here. I'm going to prove it to you how this can actually give you these without having to go through the factoring method. So I'm going to say, in fact, I'm going to just pick up. I'm going to rewrite this down here. Give me a second. Okay, so remember the A, B, and C correlates to the A value, the B value, the C value. So I'm going to plug those into their proper spots. Now, yesterday in class I showed you, and guys, remember, I've been doing this longer than you've been alive. I know what I'm talking about. Take my advice. Everywhere I had A, B, and C, I'm putting parentheses in their place and everything else that was already there, like the negative 4, the 2, the square, the negative 1 right here. I'm putting those all in. I tell you to do this because when you're new to something, if we can simplify that process, it's going to make it easier on you. So take my advice on these things. You can actually not screw up. It's possible. Okay, so try that. And then everywhere I see my A, I'm going to put a 1 in. So here was an A, so there's 1 down here, 4, and then there's A right here. The B was a negative 5. That's right, guys, I'm going to tell you hands down, that's where people are going to miss it. Because right here, you're going to put a negative 5 right here, and you're going to put a negative 5 right here. And then your C value is negative 14. So I've got all my stuff entered in. Now, I always just take care of this. I mean, negative times a negative is a positive. That's a quick, easy thing to deal with. 2 times 1 is 2. Guys, oh, and here's another thing. People forget that there's a radical sign there. Don't forget that. Right here, negative 5 squared is a positive 25. Right here I have negative 4 times 1 times negative 14. So here you go. Negative 4 times 1 times 14 negative. It's 56. Oh, are you serious? Is this not gonna be nice to me? Oh. Crack myself up. Again, not enough coffee. See? Hadn't touched it since. So 25 plus 56 is 81. So now, this happens to work out rather nicely. We actually know what the square root of 81 is. It's 9, right? So now this right here. So now remember, because you took the square root of 81, it is 9. The 9 is not under a radical. Square root of 81, 9. Square root of 81, 9. Now, right here, let me show you how to write this. Because you're actually going to write two equations. You're going to say 5 plus 9 divided by 2. And you're going to say 5 minus 9 divided by 2. 9, 10, 11, 14 over 2 is 7. That's going to give you a negative 4 over 2, which is negative 2. Back when I was doing the factoring, using quadratic formula. Look at my graph. Negative 2, 7. This quadratic formula, now, there's some stuff you got to keep up with. You got to pay attention. But in light of it all, you don't have to necessarily go back to the factoring method anymore. That's not necessary for now. This right here can help you find those roots much more easily. This right here, guys, is a crucial formula to know. Very important when you're talking about polynomials. So, let me turn my screen down here. So, I hope this video helps you out a little bit when you're practicing some of these. I think if I don't have it, I will here in a little bit. I'll put a practice page of finding these roots with the quadratic formula. I'll put a little practice sheet with the answer key and all that for you on your Google Classroom so that y'all can actually practice some of these. I think you'll catch on rather quickly to it. You just got to practice. I mean, that's the only way to get good at anything is practice it, screw up, learn from it, practice again. So, happy studying. Y'all have a great day. Bye-bye.